Hello students, welcome to the channel Eductaional. Today's topic is chemical bonds. So in this topic, we will see the points. There are three types of bonding, okay? Metal and non-metal, and definition of terms like bonding and type of bonding, and explanation of arrangement of giant ionic and covalent structures, okay? So let's begin the topic. So first, what are chemical bonds? Yes, metals are shiny elements which are good conductors of electricity. Yes, we all know that metals are good conductors of electricity. They have a giant structure and their atoms are arranged in a regular pattern. Yes, metals can be found on the left hand side of groups of 1 and 2 in the periodic table, and in the middle. Those are called transition metals. Okay. Next. First comes the metallic bonding. The electrons from the outer shell of metal atoms become delocalized. So basically, what is the meaning of delocalized? Delocalized means an electron in an atom, ion or molecule that is not connected to a single atom or a covalent bond. Okay. They are free to move. The strong electrostatic attraction. Yes, the strong electrostatic attraction between the positive ions and negative delocalized electrons results in strong metallic bonds. So now what is electrostatic attraction? The force that pulls together oppositely charged objects or particles. Okay. So this is strong electrostatic attraction. Okay. Between the positive ions and negative delocalized electrons results in a strong metallic bonds. Now, positive metal ions and delocalized electrons. First, I'll write down here what is delocalized. An electron in an atom, ion or molecule that is not connected to a single atom or covalent bond. Yes. So this is delocalized. Okay, meaning. So what is electrostatic attraction? I'll write it here. The force that pulls together oppositely charged objects or particles. Okay, particles. Once again, the electrons from the outer shell of a metal atoms become delocalized, that is, they are not connected with a single atom or a covalent bond, are free to move. The strong electrostatic attraction between the positive ions and negative delocalized electrons results in a strong metallic bonds. Okay, non-metals undergo covalent bonding, okay, and metals undergo metallic bonding. Non-metals form strong covalent bonds with other non-metal atoms. While list covalent bonds are strong, the resultant simple molecules have low MP and BP, that is low melting point and low boiling point, due to weak intermolecular forces between the molecule. Again, what is intermolecular force? The relative, yes, the relatively weak, okay, weak attractive forces that exist between the molecules. Yes, is the intermolecular force. So, once again, non-metals form strong covalent bonds with other non-metal atoms. While covalent bonds are strong, the resultant simple molecules have low melting point and low boiling point due to why? Why they have low MP and BP? Due to weak intermolecular forces, that is weak attractive forces that exist between the molecules. Okay, so metals undergo metallic bonding, whereas non-metals undergo covalent bonding, and these metals are basically found in the periodic table of group of 4 to 7. Okay, all of group 0 are non-metals, but they are inert gases. Okay, next, covalent bonding. A covalent bond is formed when two atoms share a pair of electrons. Pair mane jodi. Yes, a covalent bond is formed. See, covalent bond, who is forming? Non-metals. Yes, a covalent bond is formed when two atoms share a pair of electrons. Usually, each atom contributes one electron from their outer shell. Yes, from their outer shell. But some atoms can react to make multiple covalent bonds. Okay, here they have given sharing the electrons provides each atom in the covalent bond with the desirable full outer shell of the electrons. So each atom is been shared from the outermost shell to form a covalent bond. Covalent bond is formed when two atoms share a pair of electrons. Giant covalent. Giant covalent structures contain many atoms covalently bonded in a regular arrangement. This is known as lattice. The image shows us of graphite, okay, which is an allotrope of carbon. Okay, allotrope of carbon. Okay, graphite. See, graphite is basically found where easily you can see on the pencil nib. Okay, on the tip of the pencil. Okay, is soft because layers of carbon can slide over each other. Next, metals and non-metals undergo ionic bonding. And ionic bonding is a strong attraction between oppositely charged ions. Ionic bonding forms ions. Okay. Next, metals and non-metals react together to form ionic bonding. See, when ionic bonding is formed, when metal and non-metal react together, when they come together, they form ionic bonding. Ionic bonding. Metal atoms become positively charged ions by losing electrons, and non-metals become like negatively charged by gaining electrons. Yes, the positively charged ions are very strongly attracted to each other. So what this is called? This is called electrostatic attraction. So metal atoms become positive by losing, and non-metal become negative by gaining. Yes, so the oppositely charged ions are very strongly attracted to each other. So what we say, this is electrostatic attraction. In this example, the metal magnesium has transferred two electrons to the non-metal oxygen. Magnesium becomes a positive ion and oxygen becomes a negative ion. See, Mg2 plus. By giving it 2, it is losing, right? So it is become positive, and it is gaining. So it is becoming negative. Yes, magnesium is a metal and oxygen is a non-metal. Okay, when these two react, firstly there is an electrostatic attraction and the bonding is ionic bonding. Okay, next, ionic lattice. Ionic compounds are composed of a regular repeating structure of ions. This is known as giant ionic lattice. The lattice is held together by the electrostatic attraction of oppositely charged ions. Yes, so how this attraction is, this is electrostatic attraction. Yes, this is held by electrostatic attraction, okay, of oppositely charged ions. You can see all the ions are oppositely opposite. You cannot see all together. I mean positive one side and negative one side. No, positive and negative both are together. Thank you for watching the video and listening the video. See you in the next video. Don't forget to like, share and subscribe the channel Tutor Elite.